CCD or CMOS sensor image receptors convert X-rays to electronic signals that are then reconstructed by the computer and displayed on the monitor. A charge-coupled device, also known as CCD, is where the X-rays are transported across the silicon chip and read at one corner of the device. They tend to have higher quality and low noise due to more pixels. The structure of a charge-coupled device system is mounted under a radiographic table and is permanently affixated to it. X-rays hit a scintillator, which is composed of sensors primarily sensitive to visible light and can possibly absorb some X-rays, which then convert X-rays to light photons that are focused by a lens so an optical image is formed on the surface of a charge-coupled detector. Then the information is digitized by analog to a digital converter and sent to the computer. Typically, the light from a scintillator is coupled to the device using a focusing lens. A CCD is considered an indirect acquisition because it uses a scintillator and does not use a thin film transmitter, also known as the TFT, which is an electric switch that allows the charge collected at each pixel to be independently transferred to an external electronic where it is amplified and quantized. The advantages of using CCDs tiled together to form a flat panel indirect capture are the high efficiency, good resolution, and high dynamic range.
How digital images are created on direct capture IR and indirect capture from exposure to plate discharge. Direct capture X-rays are converted into an electrical signal, whereas indirect capture X-rays are absorbed and converted into light, which is then converted into an electrical signal that is sent to the computer for processing. In direct capture, there is conversion of X-ray energy to an electrical energy. The material used is the amorphous selenium. A photoconductor sends the electrical signal to the thin film transistor, which then sends the signal from analog to digital conversion. After the ADC signal goes to the computer for processing. After the processing, the image is ready to be viewed. In indirect capture, X-rays are absorbed and converted into light, which is then converted into an electrical signal. The scintillator, which is composed of the amorphous silicone, there is two material crystal types, the turbid, which is the barium fluorobromide, and europium. Also the needle, which is potassium iodide found in the indirect FPD scintillator layer. The conversion by CCD or TFT with the CMOS. The electrical signal is then transferred to digital image. ADC, the analog to digital conversion. Electrons are given a numeric value, binary or alphabet, depending on shades of gray or black.
Another way to look at it is viewing it through the lens of different cameras. On the left, it is as if you are looking through the lens from a CCD equivalent camera, and on the right, a CMOS camera. The right obviously has way better quality, while the left is not as good in quality, but more than likely is cheaper in price than the camera used on the right.
A pixel is a basic picture element on a display. Dynamic range is the ability of an imaging system to respond to varying levels of exposure. A bit is a single unit of data. A byte is made up of 8 bits and is the amount of memory needed to store one alphanumeric character. Bit depth is the number of bits stored per pixel. This defines the shades of gray available for each pixel. A matrix is a squared series of numbered boxes that represent a pixel intensity and give form to the image. The exposure latitude is the range of receptor exposures over which an image and contrast will be formed.